In this video, we are going to see about PN junction diode. A pure silicon crystal or germanium crystal is called as intrinsic semiconductor. A pure form of silicon crystal or germanium crystal is known as intrinsic semiconductor. There are not enough free electrons and holes in the intrinsic semiconductor to produce a usable current. To produce a usable current in the PN junction diode, we are not enough with free electrons and holes. So, the electrical actions of these can be modified by doping. To increase the usable current, we are going into the process called doping. When a crystal has been doped, it is called as extrinsic semiconductor. As we all know that extrinsic semiconductor is an impure semiconductor, and an intrinsic semiconductor is an pure semiconductor. By adding doping, we are making the intrinsic, that is pure semiconductor, into an impure extrinsic semiconductor. We have two types, that is N-type semiconductor having free electrons as majority carriers, P-type semiconductors having free holes as majority carriers. N-type semiconductors have free electrons as majority carriers, and P-type has free holes as majority carriers. If a junction is made by joining P-type semiconductor to N-type semiconductor, a useful device is produced, which is known as diode. Okay. By combining the P-type, that is free holes, and the N-type, that is free electrons, we are making into a new product called diode. It allows current to flow through it only in one direction. This PN junction diode allows the current to flow through it in one direction. Here is the PN junction diode, where we have P-type material of holes as majority carriers, and N-type materials we have electrons as minority carriers. We are combining these P-type material and N-type material into a PN-type material, that is PN junction diode, where electron and hole recombination occurs here, and the electrical charge has been produced in a high manner. PN junction diode. Holes from the P side diffuses into N side, where they recombine with free electrons. As I already told, the P-type, that is P side we have holes, and N side we have electrons, where they recombine each other with free electrons. Free electrons from N side diffuses into P side, where they recombine with free holes, where the combination of electrons and holes is happening there. The diffusion of electrons and holes is due to the fact that large number of electrons are concentrated in one area and large number of holes are concentrated in other area. Here we are going to diffuse the P-type and N-type material. So the P-type material is of large number of holes, and N-type material is of large number of electrons. We are going to combine each other. When these electrons and holes begin to diffuse across the junction, then they collide each other, and negative charges in the electrons cancels the positive charges of the holes, and both will lose their charges. Negative charges in the electrons cancels the positive charges in the holes, so both loses their charges. The diffusion of holes and electrons is an electric current referred to as an recombination current. The diffusion of holes and electrons, we are going to diffuse, that is combine holes and electrons in an electric circuit, which refers to as a recombination current. The recombination process decay exponentially with both time and distance from the junction. The recombination process decays exponentially with both time and distance from the junction. Thus, most of the recombination occurs just after the junction is made and very near to the junction. Where the electrons and holes recombination place is called as a junction, the most of the recombination occurs just the junction is made or very near to the junction. Very near to the junction, the diffusion process has been taken place. Thank you.